So I want you to just picture your morning routine for a second.
Hmm.
You wake up, maybe you grab your phone before you're even out of bed.
Oh, definitely. First thing.
Right. You check your email, you're doom scrolling through Twitter or X, whatever we're calling it these days. Maybe glance at a news feed. It feels like you're just absorbing information.
It does. It feels like that.
Hmm.
But usually it feels like way too much information. It's a flood.
Exactly. And that feeling, that sense of being overwhelmed, but, somehow still not knowing what's actually important.
Uh-huh.
That is the paradox that kicks off the research we're diving into today. The source material calls it the data paradox. We are drowning in data, but we're starving for actual knowledge.
It's such a crucial distinction they make right up front. Data is just noise. It's raw.
Yeah.
Knowledge is something you can act on.
And that gap between the two is just getting wider.
Every single second.
There is a statistic in the intro to this research that, honestly, it kind of floored me. In the enterprise world, so we're talking big companies, governments, about 80% of all their available data is unstructured.
That is the key number to keep in mind today. 80%. And think about what unstructured actually means. We're not talking about nice, neat rows and columns in a spreadsheet.
Right, we're talking about the mess. Emails, PDF contracts, messy HTML code, social media rants.
Customer support chats, PowerPoint slides. Exactly. It's text. It's human language, which is notoriously messy.
So if you're a CEO, 80% of the intelligence you need is locked inside formats that computers can't just, read in a traditional way.
And that brings us to the mission of today's deep dive, web text mining. It sounds a bit dry, I know.
A little bit, yeah.
But it's this incredible engineering challenge. How do you take that chaotic 80% jumble of words and turn it into structured, usable intelligence?
And I think we need to be clear for everyone listening, because this was my first thought. This is not just Googling it, right?
No, not at all. That's a common misconception. Google is primarily a retrieval engine. It finds documents that match your keywords.
It hands you the book.
Right. Web text mining is an extraction engine. It doesn't just hand you the book. It reads the book for you, highlights the important parts, and writes a summary.
So today we're going to look at how machines learn to read without, say, understanding poetry, how they figure out sarcasm on Twitter, and how they connect dots that seem totally unrelated.
Exactly.
So let's start with the why, because mining sounds industrial, it sounds expensive, why bother? The text lays out this business case with a multinational electronics manufacturer that I thought really grounded it.
Right. It's a perfect example because it shows the sheer scale of the problem.
Hmm.
So imagine you build laptops. You've got suppliers in Taiwan, assembly plants in China, customers everywhere.
A global operation.
A huge global operation. And you need two very specific types of intelligence just to get through the week. The first one they mentioned is situational intelligence.
Which sounds like something a spy would need.
In a way, it is. Corporate strategy can be a bit like spycraft. Situational intelligence is basically just asking, is the world on fire, and is that fire going to affect me?
Simple enough, but how does a machine help with that?
Well, think about the mechanics. Let's say an earthquake hits a specific region in Southeast Asia. That's on Yahoo. News within minutes.
Sure, but I can't read every news story in the world every minute of the day. I might miss it.
Exactly. And even if you did read it, you just know there was an earthquake. You wouldn't immediately know what it means for your Q4 shipping targets.
Ah,
A
yeah.
text mining system does something much more sophisticated. It scans the news, detects earthquake magnitude,
Mm-hmm.
but then, and this is the magic, it cross-references that with your own internal unstructured data.
Like my supplier contracts, those PDFs sitting on a server somewhere.
Right. It digs into those dusty PDF contracts and realizes, wait, the supplier for our LCD screens has a factory in that exact zip code.
Mm.
And then it can check the contract's expiration date, force majeure clauses, everything.
So it connects an external news event to an internal business risk without a human having to make that leap.
Instantly. It turns news story A into alert, supply chain risk for laptop Model X. That's situational intelligence.
Mm-hmm.
It turns the web into a radar system.
That's huge. But the second type seemed even harder to me. Customer intelligence. This isn't about facts like earthquakes, it's about feelings.
It's about listening. I mean, in the old days, you'd run a focus group, get 12 people in a room. Now your focus group is the entire internet talking about you 24/7.
But the text makes a good point that this data is incredibly noisy. If I release a new phone, I might get 10,000 tweets in an hour.
And you can't hire enough people to read them. And by the time they did, the conversation would have already moved on. This is where text mining looks for hot topics. It clusters the data.
So instead of reading 10,000 tweets,
The system tells you, hey, 40% of the conversation right now is negative, and it's specifically clustered around the keyword battery life.
It identifies the fire before it burns the house down.
Precisely. It separates the signal, the battery is bad, from the noise.
Okay, so that's the business case. We need to know if our factory's underwater and if our customers hate our battery. But I want to get into the mechanics. The text breaks this down into three main pillars. And the first is information extraction, or i.e.
i.e. is really the foundation. The text describes it as reading without reading.
I loved that phrase. It feels almost like cheating, like you're just skimming the Cliff's Notes.
It's efficient. The computer isn't trying to appreciate the prose or the deep meaning. It's just hunting for entities, attributes, and relationships. It's looking for specific things, a priori things we told it to look for beforehand.
But here's where reality sets in. The web is a mess. I've tried to copy-paste something from a website into a spreadsheet before, and it's a nightmare.
That's the dirty work of pre-processing. The text highlights this as a major hurdle. Before any algorithm can start thinking, you have to strip away the HTML tags, the ads, the navigation bar, all the junk, just to get to the plain text. And the source material specifically calls out PDFs as a villain here.
I noticed that. Why is it so hard for a computer to read a PDF? It looks like text to me.
Because a PDF is designed for printing, not for data structure. It cares about where a pixel goes on a page, not what a word actually means. So when you use a converter to turn a PDF into raw text, it often just garbles tables or mathematical symbols.
Garbage in, garbage out.
Exactly. If the converter turns a price of $500 into S500 because it misread the dollar sign, your mining algorithm is dead in the water.
Okay, so assuming we clean the text, we've wrestled the PDFs into submission, how do we extract the nuggets? The text talks about wrappers, which sounded to me like a cookie cutter.
That's a perfect analogy. Wrappers work best on templated websites. Think about a site like Amazon or Yelp.
Right. Every product page has the same layout. Title at the top, price on the right.
The structure's predictable. So you write a wrapper, a set of rules that says, go to this specific coordinate on the page and grab the text. It's called wrapper induction.
But the web isn't just Amazon. It's blogs, news sites, forums. This is the open domain problem the text talks about.
Correct. You can't use a cookie cutter on a pile of mud. You can't write a rule for every single website on Earth.
So what do? The text describes a method called DIPRE that I thought was really clever. It's a mouthful, dual iterative pattern relation extraction, but the concept felt like teaching a computer to learn by example.
Yes, DIPRE. It addresses the problem of, I don't have a giant database to train you with. It relies on the redundancy of the web itself.
So walk us through it. The example was finding authors and book titles.
Okay, so you want to find a list of every book ever written. You start with a tiny seed set. You give the computer just 5 pairs you know are true, like The Shining by Stephen King.
Just 5? That seems like nothing.
Just 5 is enough. The computer scans the web for those 5 precise phrases, and it looks at the context around them and notices a pattern. Maybe it finds a sentence that says, The Shining, written by Stephen King.
So it learns the sentence structure. It realizes that phrase, written by, probably indicates a book and an author.
Exactly. Then, and this is the genius part, it uses that new pattern to find books that weren't in your original list. It scans for that structure and finds, say, Dune, written by Frank Herbert.
And it adds that to its list automatically.
And then it uses those new books to find new patterns on new websites. It loops, it iterates.
It snowballs.
It snowballs from a tiny seed into a massive database of knowledge. It's bootstrapping its own intelligence.
That is fascinating. So we can extract facts. That feels logical. But then we hit the next section, sentiment analysis.
The challenge of human emotion.
This is where I get skeptical. I mean, humans barely understand each other's text messages. How is a machine supposed to do it?
It is the hardest problem in the field. But the rise of Web 2.0 social media forced engineers to figure it out. Companies didn't just want facts anymore. They needed to know feelings.
The text uses a laptop review to explain this, and I think it's a perfect example of why a simple thumbs-up, thumbs-down system doesn't work.
All right, let's look at the review. It says, I bought a notebook Model X. I love it. Its size is perfect, runs applications much faster. I only wish the battery wouldn't run out so fast.
Okay, so is that a positive review or a negative one?
If you just count the words love, might make the whole thing seem positive. But that's useless information for the company.
Right, because the battery engineering team needs to know they failed, even if the design team succeeded.
Exactly. This is called aspect-level sentiment analysis. The computer has to link the positive emotion, love, to the specific aspect, size. and link the negative emotion, wish it wouldn't run out, to the aspect battery.
That sounds incredibly difficult given how people actually write online. The text calls it linguistic chaos.
It is chaos. Think about a tweet, like with 3 eyes. Movie. No punctuation, slang. Standard grammar parsers they crash and burn.
So how did they solve it? The text mentions a solution that is so simple it's almost funny, emoticons.
It's brilliant, isn't it? Researchers realized they didn't have millions of labeled slang sentences to train the AI, but they did have millions of tweets ending in smiley faces.
So the user basically labeled the data for them without even knowing it.
Exactly. If a tweet ends in a colon parenthesis, the computer assumes the text before it is positive. If it's a sad face, it's negative.
They used the smiley face as a Rosetta Stone for internet slang.
And it worked. It allowed them to build these massive training sets. Now, the computer knows that like it, with 3 exclamation points, usually appears next to a happy face, so it learns that's a positive sentiment.
That is really clever. Now, applying this to the real world, the text mentions the stock market, and this blew my mind.
This is where it gets predictive. There was a study on public mood and its correlation with the stock market. But another study looked at mass mourning on Twitter after Michael Jackson died.
Why does that matter for the stock market?
It's about detecting a global shift in emotional state. If millions of people are suddenly expressing fear or panic or deep sadness, that collective mood often correlates with a drop in the Dow Jones.
So you can trade on tweets.
Hedge funds do it every day. But there's a catch. The internet is a constant stream. The text mentions a tool called TweetFeel and a concept called the sliding window kappa statistic.
Yeah, I highlighted that. Sliding window kappa. What does that actually mean in plain English?
It solves the fire hose problem. You can't let a tweet from 3 weeks ago affect your sentiment score for right now. The internet moves too fast.
So the window is the time frame, like only the last few minutes.
Right. The sliding window means the system only looks at, say, the last 15 minutes of data. As a new minute arrives, the oldest minute drops off. It constantly forgets the past to stay accurate to the present.
Got it. Okay, so we have facts from IE and feelings from sentiment. The final piece of the puzzle in the text is entity retrieval. This feels like the next generation of search.
It is. It's the shift from searching for documents to searching for things.
Okay, give me the example from the text, the Kingston Trio.
Right. So imagine you go to Google and type, what recording companies sell the Kingston Trio's songs?
Today, I'd probably get a Wikipedia page, maybe a fan site, bunch of blue links.
But you didn't ask for a website. You asked for a list. You want Capitol Records, Decca, etc. You want the actual entities.
So entity retrieval is the computer understanding that Capitol Records is a specific type of thing, a company, and just giving me that answer.
Yes. But to do that, the computer needs a brain. It needs a knowledge base. The text mentions things like Yago or Freebase.
These are like giant encyclopedias for the AI.
Think of them as giant maps of concepts. Yago knows that Paris is a city. It knows Paris is located in France and that France is a country. It has millions of these facts all linked together.
So when the algorithm sees the word Paris in a text, it's not just seeing 5 letters, it's connecting it to that entire map of knowledge.
Exactly. It understands the identity of the word. And this leads to really cool visualizations, like the prototype the text describes called the Time Explorer.
This is what I want. Instead of a list of links, it gives you a timeline.
It visualizes how entities relate to each other over time. You could search for 2 people, say a politician and a scandal, and the graph would show you when those 2 things were most strongly connected in the news.
So you can see the story unfold visually, the rise and fall of their connection.
It turns the web into a web of knowledge, not just a web of pages.
It feels like we are building this giant digital brain that's slowly learning to understand us.
That's a pretty fair assessment. It's moving from just storage to actual comprehension.
So big picture, we've gone from scraping messy HTML to learning patterns to decoding emoticons to mapping out all of knowledge. It sounds like the problem is solved. Are we there yet?
Far from it. The text is very careful to ground us here. I mean, we have these amazing prototypes like TweetFeel and Time Explorer, but the open domain is still a mess.
The text mentions that industrial applications struggle with noise that academic studies don't really face.
It's easy to get 90% accuracy in a controlled lab study. It's really hard to do it on the live web where people are spamming, lying, being sarcastic, and inventing new slang every single day. The field's maturing, but it's an ongoing battle.
I want to wrap up with a thought that struck me when we were discussing sentiment analysis. We talked about companies using this to fix products and politicians using it to win elections.
We are being watched, or at least our digital exhaust is being analyzed.
Right. And here's the question. We know this exists now. If I know that a customer service bot is analyzing my tweet for sentiment, do I change how I tweet?
That's the feedback loop.
If I know that using a frowning face gets me a coupon and a smiling face gets me ignored, I'm going to use the frowning
You
face.
start to optimize your output for the algorithm.
Yeah.
You change your behavior to get the result you want from the machine.
Exactly. So we're training the machines, but at the same time, the machines are subtly training us to communicate in ways that are easier for them to understand. We're becoming more structured to help them mine us.
That is a profound and, yeah, a slightly unsettling thought. We might be meeting the machines halfway.
Something to think about the next time you leave a review. That's all for this deep dive into web text mining. Thanks for listening, and we'll catch you on the next one.